So hi guys, thanks for coming and thanks to the organizers for having me. So yeah, first of all, my name's Joel Jacobson. I work for a company called Datastax. Anyone heard of Datastax? Put your hands up. Okay, a few. So yeah, I'm a solutions engineer, so I'm essentially part of the technical field team in Europe. So I help customers get started with Cassandra and help them diagnose problems that they run into. So first of all, who's heard of Cassandra? Okay, great, perfect. So that's the majority of you. So for the few of you that haven't heard of Cassandra, I'll just give you a quick whirlwind overview. So Cassandra essentially is a distributed NoSQL database. It's essentially a clone of Amazon Dynamo and Google's Bigtable, but essentially it's built for high availability, fault tolerance, and scalability. So the architecture essentially is it's a masterless peer-to-peer architecture. So there is no special nodes or machines or servers, right? There's no masters, there's no slaves. You can literally hit any node within your cluster and it will perform the request for you. Another thing that Cassandra does is it actually replicates data around the cluster. So if you're coming from a relational world and when you're looking to scale, you might shard subsets of your data around to different machines. Cassandra doesn't work that way because it tries to essentially avoid single points of failure within the system. So it's essentially designed for to expect failure and then handle it gracefully, essentially. So that's Cassandra at a high level overview. It's an Apache project. Over at Datastax, we actually build an enterprise distribution, which has some really cool third-party integrations. Okay, a few of those we'll just touch on. So we have fully integrated Hadoop for these batch-style analytics that you want to perform on your Cassandra data. More recently, Apache Spark. So for those who are not familiar with Spark, I always refer to it as Hadoop on steroids. It essentially does all the computations in memory as opposed to reading and writing to HDFS, so it gives you these kind of near real-time analytics and aggregations on your data. Another integration we have is Solar, so Lucene-based full-text search engine, good for faceting, geospatial, those types of things. So these are all fully integrated within Cassandra, so you can do search, analytics on the data that you have. One more thing I want to say before I move on is essentially, we actually acquired a company recently called Aurelius. And Aurelius have an open source database called TitanDB. So for those who haven't heard of Titan, it's a graph database that you could have HBase or Cassandra as the back end. So if you think of Neo4j, right? They've got a lot of traction in this space. So we're actually also building DSE graph. So not only can you do analytics on the data you have in Cassandra, you can do search, you can also be able to model these complex graphs and relationships as well. So the roadmap for Cassandra and particularly the Datastax distribution is looking really good. So this isn't really an intro to Cassandra, this is more about what to look for when you're either thinking about running Cassandra in production or you already are. Okay, so this will help you kind of look at some common problems that people run into. So I don't want this talk to be negative because Cassandra is great, right? Here's a few customers that are actually using Cassandra. Netflix have 7,000 instances now. They've just scaled up from 2,200. Apple run Cassandra at huge scale. Apple have 75,000 nodes of Cassandra running, powering some of their services. And you can see, there's lots of companies into Cassandra, but I don't want to just talk about how great Cassandra is because as with any tool, you can use it incorrectly. So I'm just going to talk about a few things. So preparation. So, hands up for your DevOps guy. I assume a lot of you are DevOps guys here. Okay, that's less hands than I thought. So these are a few tools that you should have in place, all right? And whether you're running Cassandra or not running Cassandra, actually the first one's Cassandra specific, but a few of the others you should have in place. If you're doing any kind of monitoring and these types of things, you should have in place. Oh, I do have a clicker, I forgot. So Datastax provide a nice sort of graphical interface for actually managing your nodes and seeing what's going on within your cluster. So if you're thinking about deploying Cassandra, Op Center you should definitely have, and it will work with the open source distribution as well. So this will help you, first of all, debug 90% of the problems that you'll probably run into. So that's some really cool stacks. You can, not the best resolution there, but you see things around latencies, disk utilization, these types of things. So we have a community version, which I said is free and open source. You can run it with any Cassandra. And then we have an enterprise version, which has some really, really cool backups and alerts and all these types of functionalities. So, yeah, if you're running any type of system in production, you want to have server monitoring and alerts in place, right? This is a given. If you're not doing this, you should be. So I hope that at least you take something from these slides and implement them into your environment. So things like Nagios and Asinga, and you've got hosted and open source solutions, and you want to be monitoring actually what's going on with your machines, right? Disk utilization, I/O, all these types of things, CPU. But use something. Another thing that you want to do, and this is really something that falls into the DevOps space, right? So sometimes when you're trying to debug issues, they're not actually coming from the server level or the database that you're running. They could actually be coming from the application itself. So you always want to be monitoring what is going on with your application, right? Using StatsD and Graphite. Graphite's that top one up there. Grafana is the one just below it. And graphing events, right? Every single metric that you could measure from your system, whether it's application, the full stack, you want to measure it and you want to graph it, right? You want to look at historical trends. You want to know exactly what is going on within your application. So measure everything, graph it up. For example, user signups, error rates, things like that. You should really be monitoring this stuff. And these tools are really, really great. They take a few days to set up, and if you're an ops guy, obviously you need to involve the dev guys who's writing the code to actually monitor these things. Having micro timers around code blocks and things like that, really actually getting these granular metrics from your application. Cassandra has metrics integration, so if you are using an open source monitoring tool or something, you can actually output the stats from Cassandra into one of these solutions. Another thing you want to be doing, is anyone doing this already? Put your hands up if you're doing this already. All right, not enough of you. More, please. Another thing you want to be doing is log aggregation, right? So you've got hosted solutions like Splunk, you've got really cool open source solutions like Logstash and Kibana, and you want to be aggregating as many logs from the application and the whole stack again. You want to be aggregating these as much as you can, but the thing is with logs, you want to make sure that you're actually, storing the meaningful logs, right? There's no point in running into an issue and, you've got nothing meaningful. So make sure you're logging all your errors, so if you do run into an issue, you can filter through them in a meaningful way and actually try and debug your issue. So these are things that you should have in place anyway, whether you're probably using Cassandra or not. You should definitely have these in place. So now I'm going to talk about some of the common gotchas. So part of the technical field team, I hit customers all the time, and it seems there's a common theme in people make the same mistakes with Cassandra. So let's look at a few of these. So first of all, when Cassandra writes data, essentially everything is written with a timestamp. Okay, so if you have a conflict in your system, Cassandra resolves this by comparing the timestamp. And clocks drift, right? Server clocks, they do drift at times. So you want to make sure, especially when you're working with a Cassandra distributed system, that all your clocks are always in sync. So here we have an example where, this isn't a server clock time, so I've just kind of simplified it. But here we have an instance, so we've got node A on the left and node B on the right, okay? The real time is 12 on the left. So at 12, server A has made an insert, but actually server A's server clock is at 20, okay? So it's actually 8 seconds above the real time. So it makes an insert and it's timestamped with 20, okay? Server B is actually, and then 3 seconds later, at real time 15, server B wants to delete that data, but actually server B's got the time of 10, so it's actually 5 seconds behind the actual real time. So what happens is then it issues the delete, and that delete doesn't happen. And this is something we see often with clocks that drift. So you might delete some data, and hold on, it's still there, right? So you want to make sure that you've got NTPD in place and you've got some cron job keeping these server clocks in sync at all times. Common mistake. And when we're talking distributed systems, deletes are a hard problem to solve, okay? So what happens with Cassandra, when you delete some data, that data is not actually, removed completely. It's actually marked as deleted with what we call a tombstone. Okay, so we mark data that's been deleted with a tombstone, and tombstones have timestamps, just like normal data. So at this particular time, this data was deleted, okay? And then there's mechanisms in place that actually remove the tombstones, like compaction, but I don't have time to go into things like that, but I'm going to be hanging around most of the night, so we can go into a bit more depth. So what happens then? Let's say you have the example where you have a really, really big partition, okay? So you've got 100,000 rows in a particular partition, but you've deleted 99,999 of the data there, okay? But you've got the tombstones. The data hasn't been completely removed. So then when you subsequently maybe perform a read, you have to scan through all those tombstones to actually get the right data you want. So you might be seeing issues with, this query is taking ages, what's going on? And this is a common mistake. So you want to make sure that you're running repairs and your compaction strategy is correct to get rid of these tombstones. Another common problem is not using a snitch or using the wrong snitch, okay? And what a snitch does is it helps Cassandra distribute the data in a fault-tolerant way. Okay, we've got a number of snitches that you can use. So for example, an EC2 snitch, which will do its best to basically place the data in different availability zones, for example. Okay, or you have racks, right? You have Cassandra installed in some racks, and what you don't want to have the same replicas in the same rack, right? Because if you lose a rack, you've lost the data. So what you'll do is obviously distribute the data between multiple racks, so you have that truly fault tolerance. And sometimes people don't choose the right snitch. It uses the simple snitch by default, which assumes single data center. Okay? It's usually okay to change the snitch in production if you have a small cluster. But what happens if you have a big cluster, say 60 nodes? What happens is Cassandra reshuffles the data, right? So you might see a lot of work happening if you're actually having to reshuffle the data around. So you want to be careful if you're changing the snitch with a huge cluster. Another problem we see, so the data in Cassandra is stored in what we call an SS table on disk. Okay, so it's a particular file format. And sometimes we see, so say you're running Cassandra 1.2, and you want to scale out. It's Cassandra, that's what you want to do. You want to scale out at times. And you're on 1.2, and we've just released, 2.0 has just been released, right? So you think, okay, well, I'll just rack up a node with 2.0, the latest version, and add it to the cluster. Don't do that. What can happen is sometimes with major versions, if you're incremental versions, you may not see this as an issue. But if you're jumping major versions like 1.2 to 2.0, what will happen is these SS table file formats are not compatible with the upgraded version. So if you're going to, and what will happen is you could break bootstrap, so that's when you bring a new node to the cluster, when you run repairs to kind of repair inconsistencies with the cluster, and also decommission nodes as well. So if you're going to introduce new nodes, just stick with the same version. Okay, if you're going to do upgrades, just upgrade the nodes that are already part of the cluster, and follow. There's an upgrade path, right, to go through the specific version. So just do one node at a time in place, or if you have a bigger cluster, then do a rack at a time or an availability zone at a time. Okay, but don't add new nodes to the cluster with huge version differences. Another issue you might see is you've added new nodes to the cluster, right? So Cassandra will automatically reshuffle the data and share ownership. But what you can see is that the data being streamed from the old nodes to the new nodes, those old nodes don't actually, you don't see the disk getting less full. Okay, you see that it's still just as full as it was before. So actually what happens is it's not deleted. Okay, that data is still there. So if you're adding new nodes to the cluster, make sure you run node tool cleanup. Node tool is a tool that ships with Cassandra, and it has loads and loads of really useful things for administering your cluster. So you run cleanup, and then you'll free up the disk space there. And this is a common gotcha. Otherwise, you'll run out of space just by adding new nodes. Not good. Often, when we're talking to enterprises as well, they already have these big SANs and NASs in place, right? And actually using one of these is an anti-pattern in Cassandra. Cassandra is a distributed system. It expects local storage. Use local storage, SSDs if possible. Okay? So, when you're using like a SAN, you're introducing a single point of failure, right? You lose the SAN, you've lost the data. That's not, it's not why you use Cassandra. You use Cassandra because you've distributed the data, you're having failures, doesn't matter, okay? You see higher latencies, they actually don't perform as well as an SSD or local storage. And they're expensive, right? These things are really expensive. You buy one, you pay God knows how much, and then you have another one as a hot spare, right, just in case. These things are really expensive. So Cassandra is designed for commodity, essentially disposable hardware. Server blows up, throw it away, rack up another one, okay? Do not use an EBS, do not use SAN, do not use a NAS. You will not get the performance you expect. Okay, so now we'll take a look at some diagnostic tools. So actually, more at the Cassandra level to see exactly what's going on and help you trying to trace the issue that you're having. Am I time? Shit. Okay. The first one is I/O stat. So actually finding out what is going on the disk. Okay, so really good disk stats. So, Cassandra might not be the bottleneck, right? You might be ingesting loads and loads of writes, and you think maybe Cassandra can't handle that, but actually it's the disk. So I/O stat, as you can probably see, the wait time and the queue as well. Ignore the percentage util, that's not really accurate, but what you want to see if data is being queued, being written to disk, and then you have a disk issue, and you need to swap them out. VM stat, so virtual memory stats, so find out if you're swapping, right? If you're swapping in production, and here you see swap in, swap out, these are bad. You're going to see performance problems, and then you're going to have to try and find out where these performance problems are. So we actually recommend disabling swap in Cassandra, and if the server's out of memory, it just dies. Fine. We would rather it just die and we know exactly what the problem is, because it doesn't matter. We have multiple replicas of the data. It's fine. It's not a problem. But we'd rather know exactly what the issue is. Dstar is a bit of a roll-up of the previous couple of tools. So it gives you a really nice look at network, CPU, disk, memory, etc. Again, this should be in your Swiss Army knife of tools. Really, really great tool. strace. So this is really good to find out what a particular process is doing, right? Look at all the system calls. So this example, we're just touching a file, blah text, right? And look at all the system calls that actually happen just from doing that. So this is really, really nice. And you can attach it to running processes. You can pass some flags and filter things. Again, this should be in your toolbox, 100%. Another thing, TCP dump, right? So having a look at what is going on with the network. Is the network an issue? Monitoring incoming, outgoing, all these types of things. Who is a node trying to talk to? These types of things. Again, a must-have. So I mentioned node tool. So node tool being a really great utility for administering your Cassandra nodes. So TP stats, Threadpool stats, right? So what you want to look for here, if you're seeing issues, is blocked and dropped. Okay, so for example, memtable flush writer. That's actually showing that there's, it can't write to the disk. There's a bottleneck potentially at the disk level. So then you might, you'll go and run I/O stat and see if there's, see what's going on there. And it can lead to GC issues, right? So if everything's in memory, you're going to see more frequent GC, which again, could impact performance if you've got stop the worlds, etc. Drop mutations. Again, if there's timeouts or network issues with Cassandra. Or with your, just your environment, should I say. Drop mutations mean that you've got inconsistent data. Okay, so you want to run repair. If you see drop mutations, run repair immediately to repair those inconsistencies, and it will build a Merkle tree, essentially, of all the data and compare it and resolve it. Another tool, nearly done, really nearly done. Another tool is histograms, right? So proxy histograms, there's a couple of ones here. Proxy histograms is really nice for looking at a high level of what's going on with the cluster, right? So looking at network latency, reads, writes, that type of thing. Again, really, really useful. And then you've got column family histograms. So what they will do is actually help you maybe isolate a particular table on a particular node. Okay, so, and help you identify performance problems there. So if you identify problems on a particular table in a particular node, then you might want to run some frequent queries, some queries that you normally run there and find out. You can enable tracing. And tracing actually shows you exactly what that query is doing, where it's going, what it's hitting. Okay, so you can really get good results. And if you see here, the second bottom line, you can see we've got that tombstone issue. So we've actually read no live data, and we've read 100,000 tombstones. Okay, so that's that example there. I was going to go into the JVM stuff. I don't have time. If you want to talk about the JVM afterwards, that's fine. We use the CMS and PAR-new algorithms. We can talk about that. But essentially, you want to look for spikes in GC. And we have Cassandra logging as well, which is off by default, but you can enable it. So Cassandra can log everything that's happened from the GC perspective. And JStat, which I'm sure many of you know, which is a really, really useful tool, and you can pass lots of interesting flags there. So why does all this matter? Well, this was a customer that we touched last week. And jumping on, helping them do a few tweaks, look at the drop in latency. These small things can have a massive impact on your cluster. Okay, so do all these things. Just to summarize, so, is it even Cassandra? Sometimes people will call up and say, hey, Cassandra's not working properly, and actually it's a whole load of other things that are impacting it, from the data model to the network to the disk, the hardware, everything. Nodes are flapping, coming up and down. Check Ops Center. Ops Center should be your first port of call. Okay, Ops Center is absolutely great. Look at the system metrics. If you've got slow queries, try and isolate the bottleneck, try and find out exactly what it is, check the stats, check GC, look at the histograms, enable tracing, all these types of things. Thank you.